Hello and welcome to Pre-Algebra Lesson 31. In this video, we're going to learn about dividing fractions. All right, so the lesson objectives for today, we want to learn how to find the reciprocal of a number, and then additionally, we want to learn how to divide fractions. All right, so now we're going to talk about how to find the reciprocal of a number. This is something we need when we start dividing fractions in a little while. So to find the reciprocal of a number, we interchange the numerator and denominator. So what do I mean by interchange? Well, let's start with a simple example. Let's say we had the fraction 4/5, and I want to interchange the numerator and denominator. Well, basically, I'm going to take this denominator from the fraction that I'm starting with, and that's going to become the numerator for the reciprocal. So this would be a 5 up here. And then let me put my fraction bar. I'm just going to take this numerator here from the fraction that I'm working with and drag that down into the denominator for the reciprocal. So the numerator becomes the denominator, and the denominator becomes the numerator. That's what I mean by interchange the numerator and denominator. So the reciprocal of 4/5 is going to be 5/4, and you could reverse that and say the reciprocal of 5/4 would be 4/5. Now, when we multiply a number by its reciprocal, the result is always going to be 1. So let's say we go back to 4/5, and the reciprocal is 5/4. So why is the result going to be 1? Well, think about it. This denominator becomes this numerator. So it's basically 5/5, which is 1, right? You can cross cancel here. Let's just put a 1 here and a 1 here. And then this numerator becomes this denominator. So it's 4/4, that's 1. So cancel this with this, and I'll put a 1 here and a 1 here. Well, if you multiply these together, you could just think about this as 1 times 1. That's going to give you 1. All right, so now let's look at a few problems. We are asked to find each reciprocal. So we are given 2/3. If you want to find the reciprocal, again, I'm just going to take this denominator and drag it into the numerator. And then I'm going to take this numerator and drag it down into the denominator. So the reciprocal of 2/3 will be 3/2. Again, you can go 2/3 times 3/2 if you want to check your work. So 2/2 is 1, and then 3/3 is 1. And so you have 1 times 1, which is 1. Again, the product here should always be 1. Okay, what about 8/9? So again, let's take this denominator here, bring it up into the numerator. Let's take this numerator here and drag it down into the denominator. So the reciprocal of 8/9 is going to be 9/8. All right, what about one with a negative involved? So let me take some time with this one. So if you have this set up here, the first thing you could do is just put a negative out in front, and then basically you could interchange the numerator and denominator. So I could bring the 5 up here, and then I could bring the 1 down here. So the denominator becomes the numerator becomes the denominator, and I just basically copied the negative sign. So the reciprocal here is -5/1, which is just -5. But there's other ways that you could have thought about this. You could say that this is equal to -1/5. You could also say this is equal to 1/5. Remember, a negative divided by a positive or a positive divided by a negative, that's going to give you a negative in each case. So 3 different ways to write the same thing. So you could choose to do it this way. You could say this is -1/5, and then you can bring this denominator up into the numerator, and you can bring this numerator down here into the denominator. So either way, it's going to be -5, right? 5/-1 is just -5. Okay, let's look at one more problem. So now we're given an integer. So we have -4. So what are we going to do? Well, basically, you want to change this into a fraction by writing it over 1. So I can write -4/1 like this. Dividing by 1 leaves the number unchanged. So this is still -4. So now I'm just going to take this denominator and bring it up into the numerator, and take this numerator, bring it down into the denominator. So the reciprocal of -4 is basically -1/4. You can write this again as -1/4, or you could write it as 1/-4 as we have here, or you can say it's -1/4, whatever you want to do. All right, now let's move on and talk about dividing fractions. So I have here to divide fractions. We multiply the first fraction. So that's going to be your fraction on the left. We call that the dividend in your division problem, by the reciprocal of the second fraction. So that's the fraction on the right. That's going to be your divisor in the division problem. So for example, let's just say I had something like 3/8 divided by 1/2. This first fraction, or the leftmost fraction, would be unchanged. So you would just copy that down. Then you would multiply by the reciprocal of the second fraction, or the fraction on the right. So this is times 2/1. So basically at this point, it's just a multiplication problem. So between 8 and 2, there's a common factor of 2. 8 divided by 2 is 4. 2 divided by 2 is 1. and then you would multiply 3 times 1, that's 3, over 4 times 1, that's 4. So the answer here would be 3/4. All right, so the process of dividing fractions is pretty easy overall, but some people have a really difficult time understanding where the process comes from. So on the next two examples, I'm really going to break this down. I'm going to start off with a whole number divided by a fraction. I think that's the easier one to understand. So I'm just going to start off with some things we already know. So right now I have 4 boxes on the screen, and I'm just going to say this is 1, 2, 3, and then 4, just to count them out. Now let's suppose I asked you, what is 4 divided by 4? What does that mean again? Let's go back to basic division. Well, I'm asking how many equal groups of 4 can be made from 4. So here I have 1, 2, 3, 4. So this whole thing would be a group, right? So this would be a group of 4. So 4 divided by 4 would be 1. I can make one of those groups. I think we all know that at this point. Let me get rid of this, and let me change the problem up. So let's say we said 4 divided by 2 now. So we know this equals 2, but again, I'm asking how many equal groups of 2 can be made from 4? Well, here's a group, right? So 1, 2, and then another 1, 2. So 4 divided by 2 would be 2. Now, what if I change this up a little bit and I said, what is 4 divided by 1/2? Well, using the procedure I just gave you, you could write 4 as 4 over 1, and then multiply by the reciprocal of this, which is 2 over 1. So that should give me 8. Well, let's think about this down here. What does it mean to have 1/2 of something? Well, it means I have a whole amount. Let's say it was a pizza, or in this case, a box, and I split it into 2 equal parts. And then each part is 1/2. So this right here is 1/2, and this is 1/2. Then this is 1/2, and this is 1/2. This is 1/2, and this is 1/2, and then this is 1/2, and this is 1/2. So if I go through and just count them, how many 1/2s do I have? Or how many 1/2 of a boxes do I have? Well, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, well, that starts to make a little bit of sense in terms of why I got 8 as the answer. When I say 4 divided by 1/2, what I'm actually asking is how many equal groups of 1/2 can be made from 4? Well, what you need to do is start out with the fact that you have 4 of these guys, so 4 boxes. So I'm just going to write that. And then in each box, there's going to be 2 half boxes, right? So 2 half boxes. So I need to actually multiply by 2, because here I'm getting 2, here I'm getting 2, here I'm getting 2, and here I'm getting 2. So that's why this turns into the problem 4 times 2, which gives us 8. If we go a little bit further and we think about something like 4 divided by 1/4, well, it's the same principle here. Let me go through and write these in. So this is 1/4, this is 1/4, this is 1/4, and this is 1/4. Okay, so thinking about this, if you went through and counted, what would you have? So this is 1, 2, 3, 4, and then you have 4 of those, so that's 16. So basically this turns into 4 of these boxes, 1, 2, 3, 4, and then in each box, there's 4 1/4s. So I'm just going to do 4 times 4. So this becomes 16. Again, 4 stays the same, multiply by the reciprocal of 1/4. The reciprocal of 1/4 is 4 over 1, or just 4, so this becomes 16. Okay, let me give you an alternative way to look at this. A lot of people will teach this with what we call a complex fraction. So let's say we had 4 divided by 1/2. So I'm going to write this as 4 over 1 divided by 1/2. Now, we haven't talked about complex fractions yet. We're going to get to them later on in the course. For right now, a complex fraction is a fraction that contains another fraction in its numerator, its denominator, or both. So basically, all I'm going to do is take this part right here, which is the dividend, and I'm going to bring that up here into the numerator of the complex fraction. So this is 4 over 1. So this right here is the numerator. And then I'm going to have my fraction bar. So this is the fraction bar for the complex fraction. You could think about it as the main, so the main division. And then down here, I'm going to grab my divisor, and that's going to become my denominator here for the complex fraction. So this is 1/2, and let's just say that this right here would be your denominator. Okay, so the idea with this method is you're just going to transform the denominator into 1. And in order to do that, you would multiply this 1/2 by its reciprocal, which is 2 over 1. A number times its reciprocal is always 1, like we talked about earlier. But to make that legal, you'd have to also do that to the numerator. So the problem is 4 over 1 over, and then you have 1/2. And all I'm going to do is multiply the denominator by 2 over 1, And to make that legal, I'm going to multiply the numerator by 2 over 1. So I'm basically just multiplying the numerator and denominator of the complex fraction by 2. And this would be equal to what? Well, these guys down here, these are reciprocals. So 2 over 2 is 1. So let me put a 1 here. 1 times 1 would just be 1. So the denominator of the complex fraction is 1 now. Then up here, I just do 4 over 1 times 2 over 1. So 4 times 2 would be 8. You could put over 1, I guess, if you wanted to, but 8 over 1 is just 8. So at the end of the day, this is 8 over 1, which is 8 over 1, which becomes 8. So that's another way to show where it comes from. Again, you can use either method to prove it to yourself and think about how things work. I like using the visual example with the boxes, but some people prefer this method. All right, let's look at one that's a little bit more complicated to explain. So suppose you had 1/2 divided by 1/8. Again, let's use the procedure to start. So 1/2 times the reciprocal of 1/8 is 8 over 1. And so essentially, you can think about 8 and 2 have a common factor of 2. 8 divided by 2 is 4, and then 2 divided by 2 is 1. So this is canceled. You could just write this as a 1. So it's basically 1 times 4, which is just going to be 4. How can we show this and prove that we should take 1/2 and multiply by the reciprocal of 1/8? Well, again, you could have written this as a complex fraction. So you could do that again. So you could say this is 1/2 over 1/8. And again, if I want to make this denominator for the complex fraction into 1, I'm going to multiply by the reciprocal of this fraction here. So this is times 8 over 1. And then I'm going to do that to the numerator to make that legal. So you see that this right here is going to cancel. So this is a 1, and you could put a 1 down here. So this is a 1 now. And so this would be equal to, well, basically it's this 1/2, which we're starting with over here on the left, times this 8 over 1, which is the reciprocal of this rightmost guy here, this 1 over 8. So we end up with what? Again, like we just did, 8 divided by 2 is 4, and 2 divided by 2 is 1. So this is just 1 times 4, which is going to be 4. I mean, you can go through and say this is 4 over 1, and then over 1, and then this becomes 4 over 1 like this, and this is 4, but I think we can all see that this is 4. All right, let me give you a visual explanation in terms of why 1/2 divided by 1/8 ends up giving you 1/2 times, take the reciprocal of this, it's 8. So this ends up giving you 8 over 2 is 4. Okay, so we've seen this already using the complex fraction method. But if you want to look at this visually, what you would need to do, because you're dividing by 1/8, just start with some whole amount. You could take a pizza, a box, whatever you want to work with, and you're going to divide it up into 8 equal parts. If you're working with a pizza, you're going to have 8 equal slices. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8. If I was asking myself the question, how many groups of 1/8 would be in 1? It's 1 divided by 1/8. This would be 1 times, take the reciprocal of this, so it would be 8. So this is 8. And you can go through and count that. I have 1, 2, 3, 4, 5, 6, 7, 8 1/8 in this whole pizza. Now, I don't have a whole pizza. I only have half of a pizza. So let's mark this out like this. So maybe this is going to be my half of the pizza. And I'm not really good at drawing, so I'm going to go over. But basically, if you ask yourself the question, well, how many 1/8 are there in 1/2? Well, you have 1, 2, 3, 4. So it makes sense that we're getting 4. We can visually see that. But again, why do we end up multiplying by 8? Well, 8 is the number of slices or equal parts in the whole amount. And then I don't have a whole amount. I only have half of that. So you're asking yourself the question, what is 1/2 of 8? And that's how we end up getting 4. So that's how you want to think about this. So hopefully this makes sense for you visually. You can always pause the video and think about it, or make your own example with a pizza or boxes or whatever you want to use. All right, so now that we understand the procedure, let's just blow through some problems. I think you're going to find this to be really easy once you get started. So we have 2/3 divided by 4/9. So leftmost fraction, you're going to leave that unchanged. And then we're going to multiply by the reciprocal of the rightmost fraction. So basically, I'm going to take 4/9 to find the reciprocal. That's going to be 9/4. The numerator becomes the denominator becomes the numerator. So now we can just go through and multiply. Let's cross cancel. So basically, between 2 and 4, you have a common factor of 2. So 4 divided by 2 is going to be 2. 2 divided by 2 is going to be 1. And then between 9 and 3, you have a common factor of 3. So 9 divided by 3 is 3. And then 3 divided by 3 is 1. So this right here is canceled, right? This is a 1. So basically, you're just going to have 1 times 3/2, which is 3/2. So that's going to be your answer. What about 6/7 divided by 15 over 28? So the leftmost fraction, the first fraction stays unchanged. and we're going to multiply by the reciprocal of the second fraction or the rightmost fraction. So this 28, the denominator, becomes the numerator. Then this 15, the numerator, becomes the denominator. So the reciprocal of 15 over 28 is going to be 28 over 15. Okay, now we're ready to do some multiplication. So basically looking at 28 and 7, well, 28 divided by 7 is 4. So 28 divided by 7 is 4, and 7 divided by 7 is 1. So then between 6 and 15, each is divisible by 3. So 15 divided by 3 is 5. 6 divided by 3 is 2. So what I'm left with is 2 times 4, which is 8. So that's my numerator. Over 1 times 5, that's 5. That's my denominator. So our answer here is going to be 8/5. What about 1/3 divided by 7? So the leftmost fraction, 1/3, we're going to keep that unchanged. And we're going to multiply by the reciprocal of what's on the right. Now, again, if this is not a fraction, if it's an integer or a whole number or something like that, then basically you're going to write it over 1. So let me actually change this up a little bit. Let me put divided by 7 over 1. And so this equals, you'd have 1/3 times the reciprocal of 7 over 1 is 1/7. So again, this 7, which is the numerator, becomes the denominator. This 1, which is the denominator, becomes the numerator. Now we just multiply. So nothing to cancel here. So 1 times 1 would be 1 over 3 times 7. That's going to be 21. So you get 1 over 21 as your answer. What about 2/9 divided by -4? So again, we can go 2/9 divided by -4 over 1. So let's say this equals, you have 2/9. So leftmost fraction, that's unchanged. And then times the reciprocal of the rightmost fraction. So again, the reciprocal here, let's just write -1 over 4. Again, you could write the negative down here if you want, or you can put it out in front. It really doesn't matter because when you're multiplying, a positive times a negative will give you a negative. So you could just put the negative sign in there and then forget about the signs and just work with the absolute values. So looking at it now, you can see that you have 9 and 1, nothing you can really do with that. And then you have 2 and 4. So there's a common factor of 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So we already know that this is negative. So let's just multiply 1 times 1. That's going to be 1 over 9 times 2. That's going to be 18. So the final answer here is -1 over 18. What about 12 divided by 1/3? So let's write this as 12 over 1. And then basically, instead of divided by 1/3, I'm going to go times 3 over 1. So this guy stays unchanged. I just wrote 12 is 12 over 1. And then I'm multiplying by, I'm just going to take the reciprocal of 1/3. So 3 comes up into the numerator, 1 goes down into the denominator. So now you just multiply. So 12 times 3 is 36. And this is over 1 times 1, that's 1. And of course, anything over 1 is just itself. So this just is equal to 36. All right, let's take a look at the next one. So we have -7 over 24 divided by 9 over -8. Okay, so what I'm going to do here is say the first fraction, -7 over 24, is unchanged, and then times the reciprocal of this fraction. I'm just going to put the negative out in front, and then I'll write 8/9 like this. Let me make these negatives a little bit better here. So this is -7 over 24 times -8/9. Okay, so we know that negative times negative is positive. You can put that there as a little reminder and then erase it or scratch it out after, or you could just leave it. It doesn't matter. And then I'm just going to work with the absolute values. So forget about the negative signs now. I'm going to think about, okay, well, 24 and 8, there's a common factor of 8. 24 divided by 8 is 3. 8 divided by 8 is 1. And then 7 and 9, nothing really in common there. 7 is a prime number and 9 is 3 times 3. So what I'm going to do is multiply. We're going to say 7 times 1 is 7. Remember, I already know this is positive, so forget about the negatives here. And then down here, I have 3 times 9. That's going to be 27. So again, you can erase this at this point. You know it's positive. So you would say the answer is 7 over 27. All right, let's take a look at a problem with 2 divisions involved. So here we have 3/5 divided by 21/10, and then divided by 9/11. So the way I would do this problem, I would convert these divisions into multiplication by the reciprocal. It's just going to make it a little bit faster. The other way you could do it is you could do 3/5 divided by 21/10. So you could find that result and then divide that by 9/11. So that's up to you. It will give you the exact same answer. I'm going to do this as 3/5. I'm going to convert this division to multiplication by the reciprocal. So times 10 over 21. And then I'm going to convert this division into multiplication by the reciprocal. So times 11 over 9. So once you have it written this way, now it's a little bit easier because I can go through and just cancel things in one shot. So I can say, are there any common factors that I can cancel away between any numerator and any denominator? So looking through here, I have a 3 here, and I have a 21 here. So 3 divided by 3 is 1. 21 divided by 3 is 7. So now looking at 10 and 5, well, yeah, 10 divided by 5 would be 2. 5 divided by 5 would be 1. Now looking at everything else, it looks like I'm basically done. So I would just multiply the numerators. 1 times 2 times 11, that's going to be 22, and put that over. You'd multiply the denominators. 1 times 7 times 9, that's going to be 63. So the answer here would be 22 over 63. And again, if you want to pause the video and try it a different way, you can do this division first and then get that result and then divide by this. You will still get 22 over 63.